Hey guys, what's up? This is Miss Bolin, and I am here today to talk to you about Meet the Parents. Okay, these are the most important functions that you are going to learn in Algebra and Algebra 2. Okay, and by the time this video is over, you are going to be able to describe the main characteristics of a parent function. Okay, first off, we need to recall that the domain, remember, is all possible x values. And the range is all sets of possible y values. So always domain x, range y. Okay, you also need to know all about that function notation. So any algebraic expression that defines a function is a function rule and is defined as f of x. So I was teaching you guys all about that end behavior, and as x approaches positive infinity, f of x does what? Well, f of x represents our function notation. So f of x is essentially our y. So it says when an equation is two variables and describes a function, you can use f of x. So f of x is that y. It's describing what's going on in a function. That function is like an equation, something that you can plug in, something that's solid. It's a rule, okay? And that f of x is what the function notation is. So a better way to sum that up is that the dependent variable is a function of the independent variable, which to you guys just means that y is f of x. So every time you see a y equals, that means f of x. So if you have an equation like y equals 2x plus 1, we know that that's a linear equation, but if they throw this at you, surprise, f of x equals 2x plus 1, do not let that freak you out, because this f of x means the y. Okay, they're the same thing. It's okay. It will be okay. Okay, that represents y. That's all that's saying. It's another replacement for what y is. Okay, it's kind of like back in the day where, you know, in 4th grade, your teacher was like, oh, 2 times 2 equals 4. And then all of a sudden, they came out and they said, ooh, 2.2 equals 4. Well, that dot means multiplication. So all of it's the same thing. So just like this y means f of x. So we're just replacing it. So we went from little kid term of y to big kid term of f of x. Congratulations. Okay, so next we're going to talk about meeting the parent functions. Okay, so when you think of parents, you think of like go-to people, like our foundation people. Like when we need to come to terms with something, these are our go-to people. And this is what you're going to think about with functions. So if you're thinking about a line with a graph on it, the line with a graph on it is always linear, okay? So if it is a straight line, it is always linear. So we're looking at the family. It's linear, okay? This rule is f of x equals x, which is the same thing as us saying y equals x plus 0, because it's all the same thing. Where 0 is where we start on the y-axis right there, and then that x means we're going to go up 1 over 1. Okay? So up 1 over 1, up 1 over 1, up 1. That's how you graph that. So that crazy looking f of x equals x is just this graph right here. That means our y-intercept is 0 and that our slope is 1 over 1. Okay? So don't let that freak you out. It will be okay. Next, we're going to look at the domain. For linear, your domain is never going to change. You're always going to write negative infinity to positive infinity, unless your line is going the other way. If your line is going this way, You're going from positive up here to negative down here. Okay, same thing for your range. So that's just saying where are the range, where are they coming from? It's the y values. It starts from the top, goes to the bottom, it's positive to negative. If it starts like our blue line, goes from the bottom to the top, it's negative to positive. Okay? The symmetry here is odd. We all know why. Because it's going through the O word, so it's going through the origin. If it goes through the origin, it's odd. O, origin, O, odd. Okay, now we're going to talk about something super, super important, and this is the basis of what algebra is all about. We're going to talk about that quadratic function. Okay, the quadratic functions are the functions that look like the U's. Those are my favorite. They look like parabolas. They're U's. They're awesome. Okay, these are my favorite because these represent on a graph like bottle rockets, fireworks, all kinds of things that travel in a U shape, like throwing a football, anything that you can imagine. Sports related, that is. So quadratics are represented with a exponent of 2. Okay, so if it's a quadratic, it will have an exponent of 2. Even if you pop that in your graphing calculator and you go under y equals x squared, you'll get that parent function. That parent function goes through the y-axis. Okay? The domain is always all real numbers, or you can put negative infinity to positive, or you can put all real numbers. Or if you're that smart kid, you can put the little cursive R. Okay? With the range is a little bit strange with this one because the range for this one, your graph only stays in the positive section. It is not going down here at all. So it goes from 0, that's the cutoff, that's its barrier. It doesn't go past the 0. And then it goes up, okay? So it's like looking at it like this. Okay, I'm going down, down, down. If you're going from left to right, going down, 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 up. Can't go any further, have to go back up. It does not pass that 0. So the 0 is like the bouncer. This line is like the bouncer. Can't go past. So it's 0 to infinity. Okay, our graph here is even, because if I were to throw that bad boy in half, and then I'm like, okay, I'm going to cut this in half, it would be symmetrical across the y-axis. So it would be even. Even is symmetry, okay? Odd is through the origin. All right, next we're going to talk about exponentials, and they're amazing. That's what my boy Jaden would say. So exponentials, the rule is like y is 2 to the x power. The x is the variable. And it kind of drives you crazy because you always have to remember that when you put an exponent in something, like your x is actually the variable. Like with linear, if you do like y is 2x plus 1, your variable's down here. It's all good. This is linear. We're used to our variable being right there because that's like, and then we're used to saying, oh yeah, this is the slope because it's next to the x. And then with quadratics, it's kind of normal. If you have like x squared, the x is still down here. Okay, it's still a base number. But then when you get to exponentials, this x is up here. It is the exponent. It's a little trippy. Okay, so this is a little tricky. So you need to know that the domain from here is always all real numbers again. Okay, the range, same thing. Oh, look at my neither. That needs to come down here. That's neither for symmetry. Sorry, y'all. But the range, I'll rewrite it in my pretty handwriting. So range is from 0 to infinity because you got that line. You have that line that you cannot go past. So this is your line. You can't go past the 0 line. The graph does not go past the 0 line. It's like being at a club with a bouncer. This line does not go past it, okay? It can't come over here. You don't see your graph all over here. No. The graph cannot go past this. So, your range is from 0 to positive infinity because it goes right here. It's the y values are all 0 right here, and then all of a sudden they go all the way up to positive infinity. Okay, and then next, look at the symmetry. Does it look like, can I fold that in half? No. Does it go through the 0? No. So if it doesn't go all the way through the 0, we're just going to put neither. And that's always, that is our parent function. So those are our go-to functions, okay? So looking back, oh, that is a mess. Let's go back here. I'll make it all pretty for you guys. So if we have linear, our go-to function looks like this, okay? We're always going to refer back to this one. Rate of change looks pretty, can be y equals x or f of x equals x. Our go-to function for quadratics is this one right here. Okay, that is our y equals x squared or f of x equals x squared. Okay, and then just saying that this is a go-to function because you guys will have some that look like this. Like they'll be looking like parabolas like going down here. You have some like this going up here. You'll have some like going all the way up here depending on how your equation changes. So this is just our reference point. Because when the equation changes, it actually shows us where to move it on the graph. Little bits and pieces of the equation that change are going to show us how to move the actual graph, the U parabola shape. But let me go back. Okay, so exponentials, it can look like this. It can go down like that, and then that's y equals 2 to the x power, or f of x to the 2 to the x power. So you have to really make sure that you know how to put that like little exponent in your graphing calculator. So if you don't know how to do that, please come see me. All right, I'm hoping this video helped you guys. Meet the parents is super important. You have to have that foundation. Like, subscribe me, whatever you got to do. Pass the word on. Rolling with bowling.